It's Tuesday afternoon at 4 p.m. in Switzerland, and it's Space Café WebTalk time. Our Space Café WebTalk, 33 minutes with Professor Thomas Schildknecht, will begin soon. Thank you all for joining us for our talk today, especially on this wonderful sunny day here in, at least in Berlin, but I think in across Europe, about can we protect our keyhole to the universe? As always, we appreciate your participation and ongoing feedback. Any responses are very valuable for us and help us to improve. I'm Thorsten Kriening, your host today and publisher of SpaceWatch.Global. We are a Switzerland-based online platform for information in and about space and new space activities in a geopolitical context. I know many of you are already familiar with our websites, our bi-weekly and daily newsletters, and the Space Café podcasts. If you like to build your house on Mars, listen to the last episode. It gives some hints and tips how to do that. We also keep our fan shop open online for you to support us actively and become a space watcher. The edition 1 has cool items for you, your friends, and the ones you love, and your support is needed to keep our work alive. We do that for you. If you've missed any of our previous web talks, we have an archive available on our website, in the events section, and on YouTube. We host our Space Café web talks live weekly. My guest today is someone I absolutely admire for his work on space sustainability. He is one of these guests that you want to have. His thoughts, his advice are invaluable. So it is my great pleasure to welcome Professor Dr. Thomas Schildknecht in my show today. Thomas is a leading expert on space debris, space safety, and space sustainability. Under his leadership for more than 25 years, his research group has acquired a world-class expertise in the observation on and the characterization of space debris. He's the director of the Swiss Optical Ground Station and Geodynamics Observatory Zimmerwald and the vice director of the Astronomical Institute of the University of Bern. And Wikipedia also tells you that he and his team discovered a number of supernovas and asteroids in the night sky, what is pretty cool as well. At both national and global level, he has served and continues to serve in numerous technical and policy-making committees. He is a member of the Swiss delegation of UN COPIOS and substantially contributed to the work of its working group on long-term sustainability of outer space activities. At ESA, he is currently the chair of the ESA Space Safety Advisory Group, advising the ESA director responsible for the space safety program. And Thomas, I'm absolutely grateful for having you on the show. So let's kick that off. With all the respect, I would like to call you a space environmentalist. The pristine night sky to protect is something your work focuses on. But what is it? What is your value in it?
Thanks, Thorsten. Thanks for the roses as well. So, what is the pristine night sky and why should we protect it? Many of you have probably seen this string of pearls, recently, and you see them almost every week or every night right now. I mean, they're absolutely fascinating and they're great to watch. But, you really want to look at these all the time and everywhere on Earth. So just imagine that you are in the middle of the Sahara or somewhere in the Alps. You would look up the sky and you would see hundreds of these, brilliant points moving, around in the sky. So I don't think that we want to see that all the time. So I would rather argue that protecting the pristine night sky for naked eye observations is one of the prime priorities we should have for for the near future. I mean, this is a human heritage. Humans have been looking up to the stars for millions or thousands of years at least, and have been wondering what's up there. So I think this is why I'm really all about protecting that night sky for unaided eye, I would call it.
I think we will come later to this point of protecting something versus the technical progress. I was inspired by one of the remarks you made in our pre-talk a few days back about a reservoir in the night sky or in the sky. So what do you mean by that? I mean, how can there be a reservoir like we would do it on Earth? I mean, you have a number of national parks in the Alps or so, but how will that translate? How can that work?
That's actually the real problem we are facing, and you mentioned it. I mean, here on Earth, we have what we call dark sky oases, somewhere in remote places. So we make sure that there is not too much artificial light. And we make sure, and this is very important as well, that we don't have radio noise from radio transmitters as far as possible, because we also listen to the universe in radio frequencies. But what can we do if we want to preserve somehow at least part of the night sky in the sky itself? So we have some preserved frequencies, for example, to listen to the universe, and they are protected in the sense that they should not be used by either earthbound or space-based assets. But what do we do within the optical domain? And so I have some ideas, but none of them is absolute in the sense that we can protect something in an absolute way.
Mm-hmm. We talk so much about sustainability, and we had the pleasure to be on a panel at EPFL earlier this year. So sustainability is here, it's there, everywhere. So what is your private and professional definition of sustainability in that context? Again, I think you are the last person that denies technical progress, like all of us. I mean, otherwise we wouldn't have this discussion. But
right,
where to start? Where to go, please?
I would probably first of all say that sustainable use of anything would mean that we don't use it up. I mean, we don't exhaust the resource so that future generation can still, use that resource somehow. And by resource, this is not just, raw material. It could be an environment. It could be the night sky. It could be the near-Earth environment. It could be the surface of Mars. But, by saying that, I don't mean that we have to keep it pristine. Not at all. I mean, we use resources here on Earth, and we come up with some agreements that there are limits. We want to at least keep the environment stable at a certain condition. And these conditions have to be defined, I think, by our societies, have to be defined for the night sky, for example, by humanity and not by individuals. For example, we protect our air. We have some limits, critical limits for CO2 emissions, which we agree upon. Our air is not pristine anymore. Our oceans are not pristine anymore. But we agreed on a certain level, which we keep kind of, let's say, stable. And there's a lot of compromises. There is a lot of trade-offs between, pristine environment and our benefits from using the environment.
Yeah, unfortunately, I think as we all are about to move out of this pandemic that we experienced over the last year, and where our life, our travel activities came more or less to a stillstand. I mean, nature recovered partially, and now I think, as you said, what is the trade-off between going back to a normal what we had before, or keeping up with or keeping up what we achieved here? I think that's an answer none of us can give. But please, Thomas, tell us a bit more about your setup. I mean, not everyone in the room and in our audience is familiar how astronomers work. So to watch the night sky or the sky, what is your setup? Okay, a telescope, yeah, that's easy, or a laser sword, what we can see in your virtual background. So, but what are the limits? So what can you observe? When can you observe? So help us to understand that.
I mean, there's many boundary conditions we astronomers have to live with. First of all, I mean, in my background, you see, most cases we use dark skies, so we use night skies. So now in Europe here we have summer. There's only a few hours we can use throughout one day, for example. We have boundary conditions like the weather. We don't like clouds, but there's one very important, natural source which we don't like, which is the moon, which makes, half of a month mostly unusable for some of our observations. So by saying that, I have to add that, some of our scientific research really needs the darkest places on Earth. And we need the dark hours, and we need no moon at all. And there's other, areas where we can answer scientific questions almost by using a telescope in our backyard. For example, the one, I'm working with here in Switzerland, that's not a dark oasis at all. There's a lot of artificial lightning from large cities like Milano and others. But still, we can do reasonable work in many areas of astronomy. So, as you see, I mean, some of our research really needs these unique, dark environments. And there's many others where we don't need that in an absolute sense again.
I see. Slowly but steady, we are moving now to the obstacles to space debris. So with our 3,000 plus active satellites in the sky, plus the known space debris, you're still able to conduct your work. I mean, your research, or day by day or night by night. But when will that have a limit, or will that ever has a limit? So, or to rephrase it, when does the objects we put in space start hurting your work?
It's a very good question, and actually astronomers are trying to answer that. And I always argue, the world is not black and white. There's shades and there's colors. So there's not a simple and easy answer to that question. I mean, it will not stop tomorrow if we have, instead of 20,500, if we have 20,550 objects up there or whatever. That's not as simple as that. As I mentioned, it depends on what the type of research we are doing. I mean, we have some narrow field telescope where we try to see really remote sources in a very small field of view. Chances that, we have an artificial object pointing up this observation they're very minor. But on the other hand, we have large field of view survey telescopes, which are surveying for whatever, for example, for a transient phenomena, which means gamma ray bursts. These are, unique, very special phenomena in the universe. And these observations are very, very susceptible to any kind of let's say, interference from artificial objects. So the point is rather, this window to the universe we have using ground-based observations in radio and optical frequencies, this is absolutely unique. And, if at a certain point this environment is becoming too difficult, it will prevent us from accessing the universe. That's the problem. It will prevent us to get answers to our questions like, where do we come from? Where are we going to? What's out there in the universe? Is there some other life out there? The point is, there's no awareness about that until now, because in all, the good rules we come up with in protecting the near-Earth environment, protecting it from space debris, there's not a single rule about protecting the night sky for astronomy or for humanity in general. So I think it's about awareness. It's about becoming aware there is an additional, aspect of sustainability which we have not been taking into account at all until now. And then we can, come up with these trade-offs and look at what is it worth to have access to the universe compared to, have the high-speed internet everywhere in the world, or whatever kind of trade-offs we need to take.
I think, taking your answer, there's something in what just struck me, where you said, hey, we will not be able to see these, we will not be able to continue our work on answering the large questions. Where are we coming from? Where are we going? I think at the moment, and I think that counts for every time, humanity has other challenges in general. It is a pure survival, how to deal with this pandemic, how to deal with the climate crisis, what will be the next big thing, what will we see. So, and as much as I understand this position, if that is all what we are losing, and I'm taking the question here also from Valentin, which I think that plays in very well. He asked, what will we lose if we are losing the view to the universe? Example, will we lose the ability to detect dangerous asteroids? So if that is the case, then I think there is a severe case beside in philosophical environment what we want to answer. Is that the case? I mean, you avoided to give an answer on this question. When does it start to hurt to view? I mean, we have 3,000 today satellites. I don't know, 20,000 are planned for Elan's or Constellation, and then whatever is filed at the ITU, I think 50,000 plus. I mean, where is there a number plus? And I think that comes to it. It's not just the satellites, the active ones. It's all the rest. And but I leave you as a room to answer before we talk about the dust, because I think that is something what is also very important.
That's true. So giving an answer to Valentin, I mean, yes, of course, we'll to a certain extent be losing the ability to detect very faint and potentially dangerous asteroids near Earth objects which could impact. But I don't think that as a humanity we'll live just from these kind of things, protecting the Earth from asteroids or, surviving this pandemic. It's absolutely important that we are going to survive that. But I mean, I could also answer the question, does it really save the world if we decrease the latency of an internet connection from 10 milliseconds to 1 millisecond or a microsecond? I don't think this is really absolutely necessary. For certain, things right now, we think, yes, it would be. But so, I mean, being able to do science and being able to ask these questions, I think that's a fundamental part of the humanity. It's absolutely fundamental. You know, people are asking me very often, you know, you're spending government money here to look to the sky and have fun with, you know, the universe and answering these strange questions. Yes, I do, but I think it's part of our, you know, societies, and it's an important part that we have that freedom to ask philosophical questions and have that, you know, freedom to really do science in an environment which is allowing us to do that. I mean, I think that's really the big thing about our culture. So it's not as easy as that we can, let's say, that we can trade off commercial, you know, value with science, or, you know, looking at a football game, or having a culture, or going to, you know, attending the theater or whatever. So that's a very important point. I think it's worthwhile to consider.
Absolutely, I hear you. I mean, I do have the question about the money also are prepared to, but when debris, as it is roaming around at the moment, and causes more and more problems, you also talked when we had our pre-talk about debris that collides with debris and creates smaller parts, so dust and all that, plus the dust from debris, plus the cosmic dust, or if that's the right term for it. How does that affect your work, and how that plays into it? Because for me that was absolutely new, and so I would like to hear something more.
Yeah, that's an interesting and important point. You know, if you look at the sky, there is a natural sky brightness. The sky is never as dark as you would see it in the space station. And I mean, Claude Nicollier, who is attending, I think, this webinar, he could tell you. I mean, it's absolutely fascinating to see the totally dark sky. This is not the case for many reasons, and one reason is that there is dust in our solar system, and then there's also dust, which is natural dust, you know, micrometeorites we call them, that is reflecting sunlight, and this brightens the night sky, even at the darkest location on Earth. And the point is that with space debris, you know, the final fate of space debris, with the Kessler syndrome, you know, collisions producing more small pieces, producing again more collisions, more small pieces, it will end up, you know, it will be grinded down to dust or small particles. Many of them re-entering the Earth's atmosphere, you know, there's a cleanup effect. But the question is simply, do we have already in certain size regions this dust component? Is that is that larger than the natural component? And if it is, of course, that part of the dust will increase our night sky, or the brightness of our dark part in the night sky. So, you know, currently astronomers think that we are, perhaps may have already a few percent, 5% increased night sky brightness due to, you know, artificial dust, which comes from space debris and all our activities. Something to be carefully watched, because there, you know, if that is going to happen, that will really deteriorate our general ability to do ground-based observations. We cannot hope, you know, that no debris piece or whatever is spoiling up our observations, but it will be everywhere and all the time. But for the moment being, I would say we are talking about a few percent perhaps. And some of my astronomer colleagues are very scared about having 10% increase. But again, you know, that's going to be the trade-off. Can we live with 10% increase? maybe, but hey, you have to be aware that this is going to be a penalty to the astronomers and science.
We have a wonderful question from Aman Gül, which I will take later on, about the role of the next generation and how they can help. But before that, I mean, we talked about more satellites as a result of the technical progress and our hunger for connectivity, latency, space-based services in general. I mean, who wants to navigate from A to B without GPS? Yeah, I mean, but how does astronomers respond to that and develop their work? I mean, what can you invest compared to a few satellites in the night sky? So, I mean, is that a race that you can win? I mean, it sounds for me a bit like cyber attacks versus the protection we do on the cyber side. I mean, you have these asymmetric threats. Can we compare it with your work, even that it's all in the peaceful environment, of course?
Yeah, it's a very good question. And I think, I mean, if you think of the technological development, of course, there is the technological development which made it happen that nowadays we do most of the observations we did with the Hubble Space Telescope some years ago can be done from ground-based observatories. I don't think that some of the fundamental, concerns are that, with part of that light pollution and the radio noise, which comes with it to a certain extent, cannot be there's no workaround right now, at least from point of view of technological progress. Of course, we can go to the backside of the moon, but the problem is who is going to pay for that right now? And if you compare it from a commercial side, I mean, there's no way we can win that battle, because, I mean, our most expensive telescopes are worth one satellite or one large satellite up there.
But Thomas, I think when astronomers will be able to enter the dark side of the moon, or the far side of the moon, to be precise.
The far side, not the dark.
I think then the moon orbit is already polluted with satellites as well. So we have this same but different. Yeah. Okay. We don't have clouds so far. So, but let's change the role. So may the astronomy have a role in observing and cataloging space debris? And I think you have that today already. And can you explain it a bit more on examples? So, and how, again, I'm taking this question now, how the next generation can help or work in that field here as well?
Yeah, thanks for that question. I mean, this is why I'm here. I have been starting, 30 years ago, starting to think about, hey, how can we try to assess this? At that point, perhaps not really a big problem, but assess if this is a problem already, if it is going to be a problem. And I'm always of the opinion, before we come up with rules and any recommendations whatsoever, we should have a really sound scientific, baseline to come up with conclusions. What is the best way? Where is the problem really? And what would be the most economically viable, for example, solution? I think astronomers can do a lot. And the observatory in the background here, we have been using that to look for space debris, to catalog space debris, and especially to look for new types of debris which nobody has been thinking about. We have been doing surveys, and we found, 20 years ago, we found this type of debris in high altitude orbits where nobody had been thinking about that high area to mass ratio. It turned out that most likely this is debris shed by satellites which are aging. hey, satellites aging, producing debris. Oh, that's new. Perhaps we have to do something about it. So, and I think astronomers have a great chance to contribute to that. And even with the laser ranging you see the laser sword in the back, we are doing work for characterizing objects to better understand, the current situation. We need to understand the current situation to come up with the best measures to counteract the situation. And I think for the young generation in particular, I think applying astronomical methods, and I can give you an example. I mean, we have been looking for supernovae. We have been looking for asteroids. And as you mentioned, I had the chance to discover a few of them. I used exactly these methods, tuned them a little bit to find space debris, just as one example. We characterize asteroids, rotation rates, sizes, material of asteroids, the chemical composition. I'm doing, using the same techniques now to characterize space debris, to find out, hey, this is a piece of milfoil, or this is a piece of solar panel, or whatever, which in the first place is not very important. But if you think about it, hey, if this is mostly milfoil, then we perhaps have to do something with our insulation blankets on satellites, for example, make sure that they don't delaminate, or that we bring them back, or whatever.
Okay, interesting one, and I hope, Aman, you got some inspiration what to do. I would like to pick before we come to my last question, or a question from my good friend, our good friend, Dr. Mark Skinner. Which international forum would you consider being the most promising for assuring the dark and quiet skies? So COPUS, ITU, IAU, or others. So any preferences, any thoughts on that? I mean, I would say it's a tricky one, but it's a typical Mark question. So thanks for that.
Yeah, but Mark, thanks for that question. I think, again, the world is not black and white. So, and the problem is so complex that we need to, to tackle it from all sides. So I think the IAU, International Astronomical Union, I mean, that's the forum to organize the astronomers, to find out their needs and their issues with space debris or having mega constellations up there. And that's what they do. And of course, they come up with requirements and I mean, they came up with the report, hundreds of pages, and then I have to tell my fellow friends there, but wait a moment, if you go with that to UN COPUS, forget it. I mean, you need 2 pages, a set of 10 recommendations, and that will take you a few years until we agree on these. But it's important that we agree on these and that we have it at that level as well, because that's perhaps then the forum which has an impact on national legislation. And national legislation is finally the point where, whoever is going to launch a satellite will have to comply with some requirements. For example, not being too bright in the sky up there, just as an example, or whatever kind of requirements astronomers would like to see to protect their interests. So I think, Mark, it's not a single solution, but I think IAU is very important that we come up with, make up our own minds in the astronomy community, but then we have to go to other fora and we have to involve the private actors and the industry. That's absolutely key. We have to talk, and we talk to SpaceX and we talk to others. And I think that's very beneficial, and it already turned out to have an effect, to have an impact.
Great. There's another question from Teresa, and just to mention what you said, there's not just this one solution, and I think at the moment, or this week, the legal subcommittee and UN COPUS started, and it was refreshing to see which dynamics we have. Even it's just virtual, and everyone is also invited to follow their talks and the sessions. But I think what we see right now on this space resources side, I mean, it's a breakthrough to where we come from, where everything was just accepted and everyone referred to the Moon Treaty or in terms of resources. So I think there is some progress, and yeah, it's up to us to wave the flag, to keep this discussion ongoing. And I would like to end up now with the question here Teresa Harrison brought in. Is there an opportunity to bring sustainability in space into the mainstream debates on global sustainability? Are you aware of any proposals to do this for COP26?
Very good question, and I regularly insist with my colleagues here at the university and outside, which are dealing with, the UN sustainability goals, for example, that the system Earth is not ending at 100 kilometers altitude. Nowadays, we have to include, and I mean, it's not included explicitly in the sustainability goals of the Agenda 2030, but we have to raise awareness that we have to include at least the near-Earth environment, because both ways. I mean, sustainability on Earth can only be achieved by really using the space segment and using all the data which we gain with space assets. More than 50% of the data used for, the global warming models comes from space. As simple as that. And we know a lot more. I mean, you have been mentioning navigation, telecommunication, and so on and so forth. There's much more than we think. And no, I fully agree. We should make sure that next time, near space at least, or space in general, is part somewhere covered by sustainability goals we may set up at UN or other global level.
Great. My last question is, what does your future vision of our night sky look like? And I hope that you will end up with a positive answer here and not creating a doomsday scenario for me, because then I would be totally failed with my question. So,
no,
are you trusting humanity? I mean, that's why.
Yeah, good question. No, I'm still trusting, let's say, that there is enough people who keep up the multilateral international discussion on these topics, because we cannot solve these issues, let's say, in Europe or in the United States, or with a few commercial operators agreeing on something, because, it's really global. It's a global issue, and the Chinese would like to come up with mega constellations on their own. I mean, we're here in Europe. That we decided to go ahead with the mega constellation for Europe. Russians will do probably the same. So, no, I think I'm still confident that we can tackle these questions bottom up, of course, involving industry, private operators. On the other hand, top down by having the multilateral discussion. My vision would be that, as I mentioned at the very beginning, that we keep a rather pristine night sky for naked eye observers. So, that my kids and my grandchildren can watch the sky with, perhaps a bright dot moving here and there, but it's not like a beehive of artificial objects in the sky. So it's not an artificial sky. It's still the night sky. That's one thing. And the other thing is that I hope, and I'm confident, that we can come up with preserving certain slots for astronomers, especially in the radio domain, that we keep preserving some radio frequencies which are absolutely necessary or key for astronomers, and perhaps come up with a certain level of, let's say, of a critical limit, which we try to keep constant. Even if this is 10% less or 10% brighter night sky than we have right now everywhere on Earth. I would not like that, but I think that's even better than not having this discussion and not having really the awareness, and it will just, raise in an uncontrolled way. I think that's really important. But I'm very confident that we come to that point once we are aware there is, sustainability. That's as well, not black and white. There's a lot of aspects, and that, astronomy or dark skies, this is just one aspect which has not been in the discussion until now. But I think by now, I hope at least that this event raised some awareness, and I don't think it's hopeless, in the contrary.
Thank you very much. Thank you very much, Thomas, for being my guest. And I'm afraid our 33 minutes came to an end, even so I would like to enjoy or to continue this inspiring talk. Even so it's hard stuff. I mean, it's not something we all are amused about, but it is a dialogue we have to have. Be assured we will continue following space sustainability items, topics in our future Space Cafes and in our magazine. I also would like to announce something for us very, very cool is that our new regional format, the Space Café Switzerland, which will be start after the summer break, will be hosted by Thomas Schildknecht. So I'm very happy and grateful that you agreed to that. We will see you then back as a host later this year. So everyone in the audience, please stay tuned for that. So this week holds a few more nice events for us and for you. On Thursday morning in Europe, middle of the night for the US, I'm afraid, we will have our next Space Café Australia. We are back in Australia by Annie Handmar this time, and her guest will be Dr. Tim Parsons. A day later, on the 4th of June, we have our next Space Café Russia by Elena Morozova, and with her guest, Viktor Strelets. That will be in Russian language. On the 9th, I have the pleasure, and that's also a morning Space Café, I have the pleasure to talk with Dr. Cassandra Stair, also in Australia, in Canberra. And on the 10th, the next Space Café Moribas Vox Populi will happen about space tourism, and he has a really interesting lineup of wonderful guests, including Katie Coleman, Deborah Sass, and Sarah Jane Pale, and so on. On Friday the 11th, our next Space Café Benelux with Simon van den Dries as guest from Spire Maritime will happen, and in 2 weeks I'm speaking with Professor Kazuto Suzuki from Japan. All these events are going to be online on Eventbrite, or they are already. As always, we would like to hear your feedback, so please check in with us on Twitter, Facebook, or LinkedIn. Don't forget to sign up for our daily or bi-weekly newsletter, and if you like to treat yourself with something special, become a Space Watcher today. Your support will help us. Take your credit card and visit our fan shop at shop.SpaceWatch.Global. I know I repeat myself, but it is really an honest request to you to help us. Thank you very much for your interest today, and thank you, Thomas, for this inspiring talk and being my guest. Thanks again to the entire team behind the scenes for doing their great job week by week, day by day again. I hope you all would stay safe and stay healthy. Thank you for joining us. I hope to see you next week. In the meantime, visit our website and follow us on social media. And don't forget, become a Space Watcher. Thank you very much.